In this case, you should probably try to algebraically see if these things work out. So, for example, letter A, we have a 4 on the outside of the parentheses. So what would you do here to simplify just the left-hand side of that equation? Yeah, that is distributing. So as you distribute, you get 4 times 2x, which is 8x, plus 4 times 6, which is 24. And we're going to distribute on the other side, negative 2 times negative 8x, or sorry, negative 4x. And that gives me how much? 8x. And negative 2 times negative 12 is positive 24. So I could try to simplify this a little bit. And maybe you don't need to, but we could take out the 8x's. We have 24 equals 24. So is this always, sometimes, or never true? Always, yeah. When you get the same answer equal to itself, that's going to be an always true. Okay? Make sure you are doing your distributive property correctly. Make sure you are checking your signs and doing that correctly. All right, letter B says quantity x plus 4 quantity squared equals x squared plus 16. Now, what you should do here, gentlemen, is what I would do is write this out to be x plus 4 times x plus 4, because I think you will have a better outcome if you write it out like this. Okay? So we take the first variable, multiply it by the first variable in the other one, that gives me x squared. We have x times the second variable of that second binomial, that is 4x. And then I take this 4 and multiply it here, that's another 4x. And then finally 4 times 4 here is 16. So another thing that we called this was the FOIL method. First times first, outside times outside, inside times inside, and last times last. FOIL method. That only works when you are multiplying two binomials. Now, when I simplify this, I get x squared plus 4x plus 4x is 8x plus 16. Okay? So, as I look at this, this would be 8 squared plus 8x plus 16 is equal to x squared plus 16. So, let's try to solve this for x. Okay? What could you do? What could you do at this point? Give up. No, we're not giving up. Persevere. Do I have anything that is the same on both sides that I could eliminate? X squared, so let's take out an x squared. Take out an x squared. All right, so I'm left with 8x plus 16 is equal to 16. Now what? Subtract 16. Subtract 16. 16's cancel out. I have 8x is equal to 0. Solve for x. Divide by 8. Divide by 8. X is equal to 0. So is that an always, a sometimes, or a never? That's a sometimes, because x is equal to a value that works, and that value in this case happens to be 0. And when you substitute it in, 0 plus 4 gives you 4. 4 squared is 16. 0 squared is 0. 0 plus 16 is 16. Yes. Give me just a minute. All right, letter C. See if you can simplify that and solve for x. See if you can simplify and solve for x. So if I simplify the left-hand side, Andrew, what am I going to get on the left-hand side? If I simplify the left-hand side of equation C, what do I get on the left-hand side? Say it again. Yeah. So you have like terms right here. 5x plus 2x is 7x minus 3. On the other side, you have 3x, and you can combine the negative 8 plus 5, which gives us how much? Minus 3. All right, keep solving for x. Get your x's on one side, get your numbers on the other. Okay. What is your last name, Nehemiah? Brady, isn't it? Yeah. Brady? I forgot for a minute. There you go. Hey, Chippa. 918. So what are you getting? Let's see. So take away the smaller x's from the larger x. I get 4x minus 3 equals negative 3. Add 3. Add 3. Those cancel out. 4x is equal to 0. Divide by 4. Divide by 4. X is equal to 0. Is that going to work? Is that always, sometimes, or never? That's a sometimes. Now, substitute it back in. 5x plus 2x, those are going to zero out, so you're left with negative 3 on the left. And 3 times 0 is 0, and negative 8 plus 5 is negative 3. Wait a minute. That leaves us with negative 3 is negative 3. Which is true. We didn't make any mistakes. I'm just checking. Just to make sure. Minus 3, plus 3, plus 3. Yes, that should be a sometimes. Negative 3 is equal to negative 3, so that is telling you when x is equal to 0, it is true. Okay. And the last one. We have 6x plus 3, and over on the right, you have 6 times x plus 3. So when you distribute, you get 6x plus 18. And what is that going to be? You subtract your 6x's, right? You're left with 3 equals 18. You're like, no. Is it ever going to be where 3 equals 18? No. So that's going to be a never. So we got always, sometimes, and never. Any questions about that? Yes. Or the next one. Okay. 13. 13. All right. Brownies. Sydney read the following story problem and wrote an incorrect equation to represent the situation. 5 siblings baked B number of brownies together this weekend. They threw away 15 burned brownies and split the rest evenly. each taking home 5 brownies. How many brownies did they bake? Well, first of all, I always think this is funny because when you make brownies, you just make a pan of brownies. And so the number of brownies you really have depends on how you cut it. But that's another story. So, huh? What? I know. You just make a pan of brownies, and if you want more brownies, you cut them a little smaller. Duh. Okay. 5 siblings. That means brothers and sisters, something like that. They baked B number of brownies together. They threw away 15 burned brownies, and they split the rest evenly, each taking 5 brownies. How many brownies did they bake? Sydney's incorrect equation says that B, the number of brownies they baked this weekend, minus 15 is equal to 5. So that is incorrect. What information from the word problem did Sydney forget to include in their equation? Division. What do we have to divide? Okay. So B number of brownies. They made B number of brownies. They threw away 15. Okay. And they split the rest evenly. They split the rest evenly. What are we splitting? The rest. What is the rest? How do I represent the rest? Or is it represented already? Is this the rest of the brownies right there? You made B number of brownies. You got rid of the burnt ones. Is this the rest that we're going to divide? Okay, and what do I divide that by? Why 5? Is that because they each got 5? 5 siblings. Okay, so this is being divided by the 5 siblings. And I need to make an equation, so I have to have an equal sign in here. And what do I have at the end? 5, because each of those siblings took 5 brownies with them. Brownies to home. Okay. Oh, so maybe I did this a little wrong. But what information for the word problem did she forget to include? She forgot to include that they were divided amongst 5 siblings. So she forgot to divide by that 5. What should the equation look like? You can just keep it up there and say, there it is. And what if I had to solve for this? It doesn't say this here, but how would I solve this? What am I going to multiply? Yeah, this 5 that you're dividing by, you want to undo that division. So multiply by 5 over 1, or 5, just 5, on both sides. This 5 and this 5 would cancel out. You're left with B minus 15 equals 25. You're trying to solve for B, how many brownies they had at the beginning. Add 15, add 15. So B, the number of brownies, is equal to 40. Brownies. If you just did this one, I would want to see more, because there's nothing in there that says they divided it. And yes, you do have the 25, but the equation that best replicates what's going on would be the top one. Okay? All right. Questions on 13? Okay. Fire away. What else you got? What other questions? 15. Ah, yes, everyone's favorite. Solve the following problems for the given variables. So we're not substituting any amounts in. We are just trying to solve for the variable in terms of the numbers or variables that are already there. So you are trying to isolate and solve for the first one for t. You want to get t by itself. So spill the tea. What would you do? Subtract 5r. Is 5r and t being added right now? No. So I want to undo what's happening with it right now. So they are being multiplied. To undo that multiplication, you would want to divide. So I want to divide by 5r. And whatever you do on one side of the equation, you must do to the other side. So on the right-hand side, your 5 simplify out. Fernando, are you catching some of this? Your r's cancel out, and you're left with t is equal to capital P divided by 5r. Well, gosh, that's got t by itself. Did that sound like Goofy? Good. That was my intention. So that's it. That's it, folks. Didn't know I was such a comedian, right? Math and a show. All right. K. We want to get K by itself. Right here is K. I want to isolate K. Who said that? What'd you say? Yes, that whole top numerator is being divided by W, or think of it as W as part of a fraction, the bottom part of a fraction. To get rid of a fraction, you would multiply by that denominator. And again, whatever you do on one side, you have to do on the other. The W's would cancel out. And on the left, you have W times capital G equals, and since those W's canceled out, we are not distributing. It's just 2K plus 1. And I can take out the parentheses because I can't combine those anyway. What would I do next? Cameron, what do you think you would do next if I'm trying to get K by itself? Yeah, subtract 1, subtract 1. Ones cancel out. WG minus 1, because I can't take away 1. I don't know what WG is. That's equal to 2K. And again, you're trying to solve for K, so the last thing you would do here is divide by 2, divide by 2, 2 simplify out, and K is equal to W times G minus 1, all divided by 2. Questions on that? So when you multiply by this W, make sure you are canceling out the W's. You are not going to cancel out the bottom and distribute. Don't do that. All right. And let's go to the last one, solving for H. Rodney, what do you think we should try to do to solve and get H by itself here? I heard that. You didn't hear it? Oh, you should have been listening. You want to get H by itself. Keep the H term there. We don't want to do anything with H. We want to get rid of anything else that's there. So what would I get rid of? All right, and D is tightly bound with that 2. Okay, so I want to get rid of that whole term. So how do I move it out of that right-hand side? Subtract. Good. So subtract 2D, subtract 2D. 2D or not 2D? That is the question. Yes, this is being recorded. So T minus 2D is equal to 3 times H. I'm trying to solve for H. Cameron, what would I do next? That's right. Divide by 3, divide by 3. H is equal to T minus 2D, all divided by 3. Boom. More questions? Yes.
I was going to ask you to go to the
That's fine. Yeah.
We go for
9. You know, as a teacher, you know, you have these days coming up where you're reviewing and it's like, man, I sure hope I can do these problems. It's like, oh yeah, I can. It's always a good feeling. Yes, that one came out. All right, Morgan, Courtney, and Brad, they're collecting donations for Riley Children's Hospital. Together, they collected a total of $73. Morgan collected $5 more than Brad. Oh, I shouldn't have done that first. And Courtney collected 7 less than 3 times as much money as Brad. How much money did each person collect? There's your question. Oftentimes, what is being asked in the question is going to be represented by your variable. So, how many people are we talking about that were collecting donations? 3. We have Morgan, we have Courtney, and Brad. Now, I saw yesterday someone had M, K, and B. And yes, we could do something with 3 variables, but you are not going to get very far. So that is not what you want to do. But as you read the problem, it says Morgan collected $5 more than Brad. So Morgan's amount is really based on whatever Brad has first, right? Yes? Okay. And Courtney collected 7 less than 3 times as much money as Brad had. So this problem is all about Brad. Whoops. I hate it when that happens. So, do we know how much Brad collected? No. So that is going to be the variable that we start with. Brad is the main person in this problem. Everything is based around Brad. So X is the amount that he collected. Morgan collects $5 more than Brad did. So I need to come up with some expression to show that. Plus 5. Like this? X plus 5. Yes, because we want to have the amount that Brad had plus 5. Because it's whatever he had plus 5. $5 more. Courtney collected 7 less than 3 times as much as Brad. Courtney collected 7 less than 3 times as much as Brad. What operations are going here according to the words that I have? 7 less. What operation would that imply? Subtraction. We got some subtraction, and it says she collected 7 less than 3 times. 3 times would imply an operation of multiplication, right? When you do order of operations, which do you do first? Do you do subtraction first or multiplication? Multiplication. So how do I show 3 times as much money as Brad had? 3x. And how do I show 7 less than that 3 times as much? -7. So these are all the variables for how much each person collected, and the bottom line, the total that they collected was 73. Where is that usually going to fall in your equation? At the end. So all of these are equal to 73, so that's x plus 5 plus 3x minus 7 plus x equals 73. Does it matter what order I put these in? No, because they're all just being added together. So combine your like terms. You got an x, you got a 3x, and another x for a total of how many x? 5x, thank you. And you have a 5 plus a -7. 5 and -7 gives -2. And that's equal to 73. Add 2, which gives you 5x is equal to 75. Divide by 5, divide by 5. And x is equal to 15. 15 what? Dollars. So the answer, Brad collected $15. Is that all I need? No. So if you don't answer each problem, you're going to get some points taken off. It says how much did each person collect? So x is equal to 15. What about Morgan? How much did she collect? 20. That's 15 plus 5, which is $20. And how about good old Courtney? That would be 3 times 15, which is 45 minus 7, 38. And how could I quickly check to make sure these numbers are accurate? Add them up. And when you do, 20 plus 38 is 58. 58 and 15 is 73. Yay! So to check, add to see if they equal $73. All right. Questions? Does that make sense? I forget who asked that one. But when you see a problem like this and it's got 3 or 4 people, don't come up with 3 or 4 variables. Figure out who the main person is and then use expressions based on one person. Other questions? Yes. 11. For each pair of equations, determine whether the second equation is a result of a valid operation on the first, and why. Explains why it is or why it isn't. So for letter A, 2 is equal to 2x plus 5. Oh wait, 2 divided by 2x plus 5 equals 10. Is that the result of a valid operation to give 2 equals 10 times quantity 2x plus 5? Determine whether the second is a valid. So I guess you're saying yes or no and why. So what do you think? Letter A. Yes or no and why? Who can I talk to? How about Kaylee? Letter A, going from that first equation to the second, is there something we can do that makes that valid from the first one to the second? Cancel out. What do you mean cancel out? So are you saying yes or no, first of all? Yes. Okay, yes is correct. So what would we do to cancel it out? Right. So again, this is like a fractional part. Whenever you have a fraction or something in the denominator, to eliminate that, you want to multiply by that denominator. So you multiply by 2x plus 5 for each term in between, and you get 2 equals 10 times quantity 2x plus 5. So we can say, yes, multiply 2x plus 5 on both sides of first equation. Okay? You don't have to write a book, just make sure you get it. And you might, if you want to show it and write, that would be really great. Because sometimes what you think you're writing is not what you did in the problem. All right, so the next one, letter B. 5 times quantity C plus DF is equal to 10, and 5C plus DF is equal to 10. Is there anything we can do to get from the first equation to the second? Anything to do from the first to the second? Jesse, what do you say? You got a 50-50 chance. No? That is correct. There is nothing. Why not? Yeah, Nehemiah? Mm-hmm. Yeah. So no, it doesn't follow the rules of distribution or distributor property. Follow the rules of distributive property. Okay. All right, letter C. 3x plus 7y equals 4x plus 5. Is there anything we can do to that to get the second equation of 7y minus 5 equals 1? Yes? Yes, that is true. So if we try to get it like that, we would subtract 5 and subtract 5 over here. I'm just looking at what they did. That doesn't have to be your first move. 5s would cancel out. You have 3x plus 7y minus 5 equals 4x. And we got to move the x's to the right. So subtract 3x, subtract 3x, and you get 7y minus 5 equals 1x. So why does that work? Because you used, does anybody know? And this one, it's the subtraction property of equality. Basically, you are subtracting the same amount from both sides. Subtraction property of equality. Okay. And the last one, letter D, 8x squared minus 2x equals 0, and 7x is equal to 0. Is there anything we can do to get from the first equation to the second? Add 2? Add 2x. Let's see, add 2x. So if I add 2x over here, that cancels out. I get 8x squared equals 2x. Well, that's not quite there yet. If you had, I don't think that's going to work. But if you had back at this original equation, if you saw this on a test for factoring, what would you do? What could you factor out of both of those terms? Anything else? 2 and an x. So you would divide each, and you don't have to write that 2x underneath, but I like to show people what that means. When you're factoring out, you are basically dividing. So that 2x would come out in front. 8 divided by 2 is 4. X squared divided by x is x. Minus 2x divided by 2x is 1. And that equals 0. Yeah. To pull out in front or where? No. If this was a negative in front, then I would divide it by -2. But since your first one is positive, we're just going to take out the +2. But if it was negative for the first term, then yes. Okay. Now, I end up getting this, which is simplified. Is that anything near what this is yet? No. So this is still going to be a no. You could say it doesn't follow the rules of factoring, maybe. Doesn't follow the rules of factoring. All right. What other questions? We might have time for one or part of one. Anyone? Anyone? Did you match up the equations? Which have the same solution? That one, I think, isn't it A and D and B and C? Something like that. 7 was giving lots of problems. Hey, wait, what time is it? 54. Ooh, yeah. Yes. So these I will give after school, the answers and all the work. Difference between equation and expression. As the bell's about to ring, can you give me one difference? How are they different? Nehemiah. Okay, and this is something I really want you to understand. You need to say an equation has an equal sign and the expression does not. Don't just say equation has an equal sign, okay? All right, I will send out the rest of it later. I have tutoring today after school. What? I wrote you the pass. I forgot. You forgot. Okay.